Go. All right. Now, again, please speak up as soon as you get behind. All right. The first part is super easy. All right. Determine whether each relation, some of you don't know what a relation is. I already said a relation is just simply a set of ordered pairs. All right. A relation is a set of ordered pairs. A function is a special relation. It's so special that when you go to high school, some schools call it analysis of functions. All right. You're analyzing certain functions. All right. Functions are special relations. All right. Now, you just have to kind of understand what I'm telling you. Later, as you progress in your math, they will teach you the significance of what is a function. All right. But right now, I just need you to know that the x values cannot repeat in order to be a function. All right. The x values cannot repeat. All right. In order to be a function. All right. Did I say anything about the y values? No. Can the y values repeat? Yes, because I didn't make any restrictions. All I know is that in order to be classified as a function, the x values must all be different. In other words, each x must be mapped to a single y. X must have a single y value. All right. So if I'm looking at number one, what did they call the domain? What do we mean by domain? Those are the x values. So if you forgot that, all right, I need everybody to understand domain is me when I'm talking about the x value, and range is when I'm talking to the what? To the y values. Come on, guys. All right, this is just basic information everybody can know. Palmer, are you with me? Yeah. What are you writing on your iPad for? You don't need to get on there. It's right up there on the board. All right, come sit over here then. All right, sit right one step closer. Come on, this is what I'm talking about, fixing your problems. You understand me, right? I don't have an assigned seat for that reason. All right? So, someone who's brave. Number one, is that a function? Yes. All of the x values are different. All of the x values are different. So number one is yes. Now I'd like everybody to take a look at what I'm doing now. I'm adjusting number one. Is it a function now? No, because -4 goes to how many y values? 2, right? -4 goes to -1, and -4 goes to 4. So is it a function now? No, it's not. All right. What? What did you say when you got 2, you went down 2 with the ring? Just listen one more time. Is number one a function now? Yes, because all of the x values are different. Do we agree? And each x is going to a single y. Do we agree with that? Come on, tell me, talk to me. You're and listen to me, you guys. I'm loud, so put your hand down for a minute, Greek. Everyone else. I want to help you, right? I'm loud because I want you to hear me. Do you understand what I'm saying, right? It has no reflection on you. It's a reflection of me if you don't understand what I'm saying. I'm trying to make sure you understand. You hear me? I'm asking you, do you understand right now it is a function? Yes or no? It's a function. Everybody agree? Now I just drew this. I said I'm going to draw from here to here. Is it a function now? No, because this x value goes to how many different numbers? 2. Is it allowed to go to 2 numbers? No. Can the y's repeat? Yes. Can the x's repeat? No. So right now, as I drew it, it's no longer a function. But I was just demonstrating what is and what is not a function. Are you happy with that explanation, Mr. Williams? You good? So now everybody's going to look at number 2. Are all the x values different? No. So it is what? Not a function. That's how simple this is. I'm going to number 3. Is that a function? No, because I just looked, all I'm doing is I'm looking at the x's. 2, -1, 5, 2. Is that a function? No, because the 2's are written twice. All right. Now, number 4, you're not supposed to know this. And personally, if I was making this book, I would just cross that one out. But I want to tell you, this is the equation of a line. I want everybody to make sure you write that down. Y equals 1/2 x minus 6 is the equation of a line. All right. And I'm not going to put that on the test because I don't think you should know it. But lines are functions. So you would say, yes, because you understand that's a line, it is a function. All right. There's only one line that's not a function, and we'll talk about that when we get to it. But right now, y equals 1/2 x minus 6 is called a line. So we classify that as a function. All lines are functions. Now let's look at well, not all lines. There's one that's not. All right, but we'll talk about it when it's necessary. Come on. What? Okay, now let's look at number 5. All right, the easiest way to determine if this is a function is by drawing what's called a vertical line. All right, so watch. I'm going to draw a vertical line, and then I need everyone's attention. All right, so you can see, all right, what I'm talking about when I draw this vertical line. Oh, that was too big. Sorry.
You just press the juice.
Here we go. Here we go. Right here. I got you. Don't worry. Here we go. So I'm looking at this right here now. All right. Now, what I'm going to do is this vertical line. If you draw a vertical line and you're going to run this vertical line over your graph. All right. Let me show you what I mean by that. As I'm doing this, scanning this vertical line this way, notice that each line goes and touches the x-axis once. Do I agree with that? As I'm going, it touches it once. Do we agree? Right? So as long as I move this across the x-axis and it touches it once, it's a function. Is that still a function? Yes. Is it a function? Yes. Is it a function? No, because that x is mapped to 2 y's. So it's not a function. This number 5 is not a function because as I scroll across, now it's not a function because that x has 2 y's. So number 5, you put no. What? Bless you. Shh. Okay, so what's the coordinate of this point right here, kiddo? You're right, 0, 1. What's the coordinate of this point right here? 6, I think. You see it, understand now? The x value has 2 y values. The y values are different. It's the x value that's the same. That was a good question. All right. That's the logic behind it. All right. So now what I'm going to do is I'm going to go to the next one. Scroll over to number 6. Is that a function?
Yes.
Yes, because it only touches once. Do we agree? Right. Each vertical line passes through the graph only once. That's called the vertical line test. All right, that's how you can quickly determine if you have a graph, if it's a function. Good, Greep, go. Understand what? Well, this vertical line, does it touch 2 points?
Yeah.
Then it's not a function. Okay. Over here, show me where the line touches 2 points. You cannot.
Where are the points?
All the points that are on this graph, buddy. That's a good question too. Come on, I like what you're asking me. There's all these points on the graph. Do you agree with me? There's a bunch of points on that graph, right? So if as I'm passing through it, it touches exactly each one of them once. So it's a function. Right, now look at this one, number 8. Come on, Greet, eyes up. Is this a function? Keep your mouth quiet. I want to hear Greek. Is that a function? No, exactly. Because it touches here and here, right? So that's what the vertical line says. The vertical line test says it's touches at only one point. Over here, is 7 a function? I know it's kind of hard to see, but yes. All right. These are always going up, right? But they never become vertical. That one's a little bit harder to see, so I'll make this the question. All right, I'm gonna show you this. Instead of doing that, because it does appear, your graph it should more look like this. Sorry, one more try. Your graph should look almost like that. You with me? I don't want to look at, if it goes straight up, it's no longer a function. What?
So did you say 7 and else?
Yes, it is a function.
Well, when you go across the line, that's 1 point.
I know what you're thinking, girl. That's why I said I don't like this problem very much. But it's supposed to just touch it once, right? It only touches once, right? This arrow is making you seem like it touches more than once. Listen to me. Hey, I appreciate your thinking, right? Don't worry about number 7 right now because it's not a very good picture. Okay, this would be a better picture, like the ugly graph that I drew over here. You're supposed to be able to see that that only touches once now. Do you agree? All right, don't worry about, I'm not trying to trick you on these either, right? I'm just trying to give you a basic definition. Okay, so don't worry about it. I'm not going to make it complicated. It'll be obvious like number 8. You can see how that's obviously not a function, right? 7's not so obvious. All right, so I have to do a better job with the picture and the explanation. All right, but that one is, and if you're confused about it, just don't worry about it. What? Quickly. Okay, number 2. That's not a graph. Is that a function? Because these are used twice. Is this a function? Yeah, because all the x's are different. Is this a function? Number 3. No, because the x's, there's 2 2's. That's the best I can do. So I gave you every possibility. There's a mapping, there's a table, and there's graphs. Those are the only 3 things you're going to have to determine whether it's a function. Okay? All right. Now, this again, I don't really care if you write down number 9. I really appreciate you listening. I think that's sometimes easier at the moment. Some of you guys are writing things down. I'm totally fine with that also. All right. So the table shows the total enrollment of the U.S. public schools. Write a set of ordered pairs. I'm not going to make you write the ordered pairs, right? That represent the table. X is the number of schools since 2012, 2013. So the first ordered pair, what would be the first X coordinate? You don't have to write it down. Just tell me. What would be the first X coordinate? Tell me.
First X would be 4, 9.
You're good. The first X would be 0. All right, because the school year they're telling you starts 2012, 2013. Right. Stop. It's okay. Come on, guys. Just we're good. All right, we're good. All right, is everybody with me on that? All right. All right. Now, let me pop it back up again. All right. Relax, relax. It's coming back up. Where is my... All right, just give me a second. I'm going to pause this thing. Well, in this case, it says X is the number of school years since 2012. That means 2012, 2013 is going to be 0. And then the Y coordinate is going to be 4, 9, 7, 7. Please don't write this out. I'm not making you write all those numbers down. All right. Then the next X would be what? Would be what? 0 is, this is 0. So this would be what?
1,
1. This would be what?
2,
And this would be,
3.
and these are all of the Y values. What? I just, can you get to the question? What is the question? Because in the direction it says X is the number of school years since 2012, 2013. You have to read it. 2012, 2013, we're not going to put a bunch of numbers there. I want a coordinate. I can't graph 2012 and 2013. That's an X coordinate. The X coordinate is going to be 0. Every year after that is going to be a 1. Then the next year after that is going to be a what? 2. And then after that, it's going to be a 3. These are the number of students. Do we agree with that? Yes? All right. Do I want to really graph 49,771? No, I don't. All right. I'm just trying to show you how to write those as an ordered pair. What's the domain? What's again the domain, guys? The X values. What's the range? The Y values. Would this be classified as a function? Yes, because why? The X's don't repeat. That's it. That's all. What, Greep? Come on, knocking your head against the table's not helping. What? Are you listening?
Yeah.
Come on. All right. Now, the tricky stuff. All right. I don't really care about number 10. All right. So now you kind of start your homework. Number 11. This is the one you need to write down. This is where people have all kinds of problems. All right. Now, we are going to start what's referred to as functional notation. All right. We're going to oftentimes talk about multiple graphs, and we're going to talk about multiple functions. These are two separate functions. We call one an F, and we call one a what? A G. All right. Notice this symbolism right here inside the parentheses. What's inside the parentheses? What letter? X. What's inside the parentheses here? X. What's inside the parentheses is always the X value. What's inside the parentheses is the X. To solve the problem, you just plug that number in for X. You just plug that number in for X. All right. So if I say, for example, F of -3. Now, again, this is where people, it's hard. So you can't daydream. All right. I want you for number 11. I want you to write down X equals -3. And then what I want you to write next to that is I want you to say Y equals a question mark. We don't know what the Y is. We know what X is, but we don't know what Y is. So how do I figure out what Y is? F of X, I want you to put in your notes, F of X means Y. F of X is equal to Y. All right, and I'll go into more details, but no daydreaming right now. None. F of X equals Y. So in this position, I'm going to plug -3 in for X. I'm going to draw an arrow. All right, and I want everybody to follow my arrow. -3 goes in for X right there. Why didn't the -3 go into this X over here? Because that's for G. That's how easy it is. If you're paying attention, that's how easy. What's inside the parentheses is what? X. Palmer, keep your eyes up on the board. All right. -3 goes in for X. When you solve it, that's the what? That's the Y value. So I'm now going to plug -3. So on your notes, you write F of negative 3 equals 6 times negative 3 plus 7. And because we are brilliant, what's 6 times negative 3? Negative 18. What's negative 18 plus 7? Negative 11. So f of negative 3 equals negative 11. What does that mean? That means that the y value that corresponds to that x value is negative 11. So underneath that, I just want you to write the point, negative 3, negative 11. Negative 3, negative 11. Is everybody with me on that? All right. Now, I don't like these f of m, all right? I don't like this because right now we haven't had enough, what? You have your hand up. That means you're confused. Just tell me what. Here's the function right here, Peter. 6 times x plus 7. Okay. Now, number 12, please don't, just because we have letters here, it's the same principle. What does x equal in 12? Yes, very good. X equals m. I'm looking for the y value. So what do I put in for x? M. So I go to the f function. I'm putting down f of m. F of m equals 6. What do I replace x with? M plus 7. My answer, what's 6 times m? 6m plus 7. No, you cannot add a number and a variable. It's okay if you made that mistake, though, whoever did. That's the answer. It doesn't matter. That's the answer. So what does that mean? That means that m, comma, 6m plus 7 is on the graph. M, comma, 6m plus 7 is on the graph. Good, Mr. Greep. Come on.
So did we just replace x with m?
You are amazing. That's exactly correct. Because that's the question. They're telling you to put m in for x. That is why. M is any number that you want it to be.
Do I want to make it something?
No, no. It's a letter. It's unknown. Okay? All right. I like it. Come on. Let's do the next one. F of r minus 2. What does x equal? R minus 2. All right? X equals r minus 2. So I'm going to where x is. All right? F of r minus 2 equals 6 parentheses r minus 2, and then what was it? Plus 7. Thank you. All right, now let's see if we remember how to distribute the 6. When I distribute the 6, what do I get? 6r minus what? 12 plus 7. What's negative 12 plus 7? Negative 5. Beautiful. All right. So I'm going to write f of r minus 2. I know that's hard for you guys. I promise you. Don't just follow me along. All right. I promise. All right. So that means r minus 2, comma, 6r minus 5 is on the graph. That's what that means. All right. You're just finding y values. That's what you're doing. Come on. Stay with me. I know no one in here knows. All right. Everyone's at the same exact spot. You're separating yourself by paying attention. That's what it is. All right. Now I'm on number 14. Everybody's looking at number 14. So what do I do on number 14? Who's been paying attention? Caroline, thank you. Come on, hurry up, girl. I said, is everybody okay? And now all of a sudden you're raising your hand. What? Six R what? Because x is the whole r minus 2. I'm replacing x with r minus 2. You with me? I'm replacing x with r minus. When you make a replacement, come on, look at me. It's parentheses. You with me? You're putting it in. The whole thing goes in. All right. That was actually a good question. Thank you. All right. Now I'm back to number 14. G of 5. What does that mean I have to do? Good. Thank you, Liv. X equals 5. Perfect. X equals 5. So what do I do to solve this problem? Listen to her. You are awesome, girl. Thank you for listening. All right. 5 squared minus 4. Anybody can tell me 5 squared minus 4 is what?
21.
Nope. 5 squared is what?
Oh, 25.
Then minus 4. You're right. I know. You're okay. That's perfect. You're still no problem. I'm just being careful. That's all. 5 squared is 25. Does everybody agree? And then minus 4 is what? So what does that mean? Someone tells me what that means. What does that mean?
It means 0 and then comma 21.
Nope, not 0. 5 comma 21 is on the graph. 5 comma 21 is on the graph. What? X equals 5. You're finding what the Y value is. Hey, listen to me. Guys, I'm just being loud, so I want you to hear me. Right? You understand what I'm saying, right? This is not easy. I'm agreeing with you. If you're paying attention, it gets better. All right? What? What did you want me to do with it?
I just don't know why you squared it.
Where's the G function? Come on, you're super smart. Where's the G function? Look up. Where is the G function?
Oh.
Come on. You asked me about the F function also. Right next to it is the what? G function. You're good, buddy. You see what I'm trying to show you? Observant. All right, that's what I need you to be. What? Greep.
How do you know what you're putting in?
How do I know what am I putting on the graph? What does that mean?
Like,
Shh.
what even is it?
X squared minus 4. The G function is right here.
Yeah.
I'm plugging 5 in for X. What's 5 squared? Is 6x plus 7 on
You keep saying on the graph.
Okay. Oh, okay. Listen to me. All right. That's my fault. You ready? There are 2 functions up here. Function F and function G. Those are both graphs, but that aren't drawn. You with me now, right? Listen to me. That's a good question. I appreciate it. You hear me? All right, Peter, same with you. All right, good questions. All right, we're trying to help. This is the first time where I say it's kind of hard. Next week it'll be back to easy because we're just doing that. But I need to show you this. All right, they made it way too hard. That's why I didn't like this section. All right. So now, what I want to do is I just want to talk about, I don't want to do 15. I don't want to do 16. I don't want to do 17. I'm going to look at 18 right now. All right. I want to look at 18. All right. So here we go. All right. I would like someone, come on now. I would like someone who's been listening to me to tell me what f of 2 is. Miss Lupin, what is f of 2? I want the answer. Shh. What? Say it again. Of course it's 19. Very good. How did you know it's 9? Don't look with your face all crinkled up going, oh my gosh, how is that? She got 19 because she listened. Everyone in here can listen. So she's going to explain it obviously better than I can. So listen to Katie and see if you understand what she's telling you. Tell me, how did I get 19? I plugged the 2 in for X. Now, why in the world did you plug it into the F function? Because it's the F function. I don't know what else to tell you. We can't do a better job than that. So plug 2 in for X, and 6 times 2 today is, and then I add 7. So what is that? 19. Now, because you're so brilliant, I appreciate that. Now, I'd like someone else to tell me what G of 2 is. Why is it 0? Wow, I'm proud of myself. 0. G of 2 is 0. Now, you are not allowed to write down 0 unless you know why it's 0. You're just not. It's not helpful. That's what some of your problems are. You just write things down because you heard me say it or you heard someone else say it, and you have no idea what's going on. The only way you're going to change that is if you speak up and say, man, I'm a little bit year older and wiser. If I want to be smart, I got to listen. That's not difficult. If you're sitting there going, well, it's difficult for me, that means you're not listening, you're not asking questions. Tell me again. Well, what is X? So where did you put 2 in for? Which function? Why did you put it into F when it clearly has a G? You see what I'm saying, right? Look right here. I'm going to highlight it. This is G. Do you agree with me? Now, listen to me. You understand, I appreciate how hard you're working. Do you hear me? And I always want you to continue asking. That's the only way you're going to get much better. All right? They're asking for G of 2. Do you agree? So you plug 2 in here. You agree with that? Did you see what I highlighted? And now you can do the mental math, right? And now, of course, we know 19 plus 0 is what? 19. That's your answer. Very good. Greep, how am I doing? Good. Anybody else? Right? All right, here we go. Now, I want you to put at the top of your paper. All right, here's your assignment. All right. I'm gonna cross out some just for now. I don't like that. Man, they just didn't do me very good here. All right, I want you, not that, not that, not that. All right, so here's your assignment. All right, we're gonna go with, everybody put this on your paper, 20 through 25, comma, 27 through 38. 27 through 38. All right, I feel like that's fair. All right, now listen, tomorrow I want everyone to come in who doesn't know how to do 37 and 38. I didn't explain that one, but I want to see if you can think it through. Is everybody with me on that? 37 and 38 are the only ones that you don't know how to do, but you know how to do if you're a thinker. All right, don't just come in tomorrow without trying. I want everybody to try 37 and 38. All right, everybody's good on that? All right, I have no idea what time the bell rings, but I'm sure it's going to be soon. Can anybody tell me what time the bell rings? Right now. Oh, wow. Good job. Guys, that was fantastic. Fantastic. What do we have now, guys?